Hello again, it's me, Derek from Tomcat Gas Training, and welcome to this video all about these. What are they then? Well, these are expansion vessels. So this video is going to be all about how we size them and what they do. We're also going to be using the angle grinder to cut them up to find out what's inside them. But before we get into that, please could you take some time to subscribe, because it helps the channel, and don't forget to hit that notification bell because you want YouTube to tell you when we're uploading videos, Mondays and Wednesdays. So without further ado and messing about, let's get on with it. Now you can see the boilers I've got here behind me. I've got expansion vessels in there. So let's find out exactly what expansion vessels are and what they do. Now, as a heating engineer, there are going to be two different types of expansion vessels you're going to come across. One solely used for central heating and one solely used for hot water or potable water. Let's have a look at the central heating one first. So this is a central heating expansion vessel. And what happens with these is water comes in here, and this big steel container is separated by a butyl rubber diaphragm. And on this side, from where the Schreider valve is, so this is the same kind of thing you'd find on your bicycle tyres, this is where air is put into it. So we've got air on this side of the diaphragm, and we've got central heating water on this side of the diaphragm. I'm going to be cutting these open so you're going to see what it looks like in a minute. So what happens is, when the central heating water is heated, it expands. So from 4 degrees to 100 degrees, it expands by 4% at sea level. And if you go from 100 degrees, it will expand 1600 times its own volume, turns into steam. And if it goes from 4 degrees to minus 260 degrees, it expands by 10%. So these expansion vessels are designed to take up that expansion of the hot water, because the water side can't be compressed but the air side can be. So this rubber butyl diaphragm moves up and down to do that, because you can't compress water but you can compress the air within this vessel. So the air within this vessel, as I said, is nitrogen. Now, why did they use nitrogen? So these diaphragms are semi-permeable to gases. So basically what that means is the air can pass through the rubber over a period of time. So if they just used air, so like you get from your bike pump tyre, then it would dissolve into the rubber and into the water quicker than nitrogen, because the air is about 78% nitrogen, so you can still top it up with that. So that expansion vessel is used for central heating, and like I say, one side of the diaphragm is air, the other side is the central heating water. And you'll find these inside your combi boilers or your system boilers. You won't find them on regular boilers. Unless you are sealing the system, then you need to put a remote expansion vessel in. We're going to be looking at sizing expansion vessels at the end. So you'll be able to see that in a bit when I cut it open. Now the next one is this one, and this is the potable water one. So the way you can see the difference is, first of all, it's more of a rounded shape rather than a disc shape, and also this one has a flange on the bottom. This is where the hot water would expand up there, and this is the Schreider valve where the air would be, and this would be filled with nitrogen again. But inside this one is a rubber bag, a butyl rubber bag. And another reason why they use butyl is it doesn't change the taste in the water, so they say. But that's the difference. This one is filled with a bag of nitrogen, where the central heating one is filled with a diaphragm and nitrogen. But again, if we do lose the air, we can top it up using a pump, and I'm going to show you how to do that soon. So that's the major differences with the expansion vessels and what expansion vessels do. Now this is an unvented cylinder, and this is where the white expansion vessel goes, so the potable water one. But this heat race hardier one, this Megaflow, doesn't have one because it has an internal bubble. So what's basically inside here is like a big wagon wheel, which is connected to the hot water out pipe, which comes down to near where the temperature pressure relief valve is. So because they take the water from down here, gives a buffer here, and this big wagon wheel goes up and down as the water expands. So this has an internal expansion vessel. There's another manufacturer does kind of the same thing for their cylinders. So this doesn't need an expansion vessel on the outside, which is normally connected on either the combination valve here or actually in the cold water supply pipe down into the bottom of the cylinder. So that's where the expansion vessel would normally go on here. So that's an unvented cylinder that doesn't require an expansion vessel because it has one built in. Now we've got two different types of expansion vessels here, like I've just been saying. This is a central heating one, which we're going to be cutting up, and this is the hot water one. So I'm going to cut the central heating one up because, as you already know now, that the diaphragm is held in with this section here. So this side is the air side and this is the water side. So what I'm going to do is I'm going to cut a section out of here so we can see what's inside there. Hopefully that's what we're going to do. So I've got my angle grinder and I need to put my PPE on. So first of all, let's get my specs on. And then I can put my ear defenders on. And I can start shouting again. So, here goes. Remember, when you're using something like this, always follow the safety precautions from the manufacturer. I am actually using a steel cutting blade here, and always remember your PPE. That's one side cut. Just need to do the same on the other. can now see inside this diaphragm. So that's that one cut open. Let's give this one a go. So I've made a little frame. Hopefully it's going to stop it spinning. We'll see. That were easy. So now you can see the diaphragm is actually in the bag like we say inside there. So let's have a closer look then. Now let's have a look at the central heating one first. So we can see here, this is where the central heating water comes in. And on this back side of the diaphragm here, this is where the water would expand and push against the diaphragm, which would then compress the air on the other side, or the nitrogen on the other side. And if you look closely, can you see that down there? There's actually water in the air side of this expansion vessel. That's why it's here. So it actually didn't work. So that's the water side and that's the air side, and you can see that's what the diaphragm would be doing, because you can compress the air but not the water. So that's the central heating one. Now let's have a look at the potable water expansion vessel. So again, this is where the potable water would go in, so fluid category 2 water would go in there and it would go into the bag. So all the other space around it is taken up by the air, so you can see the Schreider valve there. So you can see the bag keeps the potable water completely separated from the steel vessel. So that's what you'd find inside this potable water expansion vessel. So as you can see here, not all the central heating expansion vessels are like big discs. They can also be kind of ball shaped. And this is an external expansion vessel going to a heat only boiler. And as you can see, the connection here is on the return as close as we can to the actual boiler. So if you do have to put a remote expansion vessel on, it should go on the return as close as you can to the boiler. And the reason why we put it onto the return is so we don't get the excessive heat which we would on the flow. So we would be getting a lot cooler water coming back, which would prolong the life of the diaphragm within this vessel. So that's why they go on the return as close as we can to the boiler. So that's how you would fit an external expansion vessel on a heat only boiler. Now let's have a look at how we are going to size this expansion vessel for a central heating system. It's pretty much the same way as sizing for potable water, but we'll look at that at the end. So these are the things that we need to do here. So in order to size this expansion vessel, we need to know, first of all, how much water is in the entire heating system. So how are we going to do that then? Well, basically, if you have got a meter on the cold water inlet, you could actually use the meter to tell you how many litres of water it's taken to fill your heating system. That's one way of doing it. Another way of doing it is find out how much water is held in a radiator in your boiler and your pipework and your fittings. But that could take some time. What do we need to do next? We need to know our maximum operating temperature of the heating system. So the maximum temperature of the central heating system will be whatever you set the boiler to. Whether it's 70, 75, 80, 82, depending on what your boiler is. I would always take the maximum rating of your boiler. So if your boiler can go up to 82 degrees, set it to that as your maximum. If your boiler can go to 75 degrees, then set it to that. So that's important because anybody could change those settings once you've left. What's next? We need to know our maximum working pressure in the heating system. So that's going to be what your safety discharge pipe will blow off at, so your pressure relief valve. And in a central heating system that is normally set to 3 bar. So 3 bar would be your maximum working pressure. What's next? We need to know the elevation of the heating system or highest point above the expansion vessel. So what do we mean by that then? Well, basically, if you're going to put your expansion vessel low down on the floor, then from the top of the expansion vessel, you need to measure then to your highest point in the heating system. So that would probably be your radiator on your top floor or first floor, second floor, whatever. So that's the distance we need in meters. So that's what we mean by that. What's next? We need to know the minimum requirements of the pressure in the heating system or the lowest pressure in the boiler will still operate at. So this minimum pressure will be what the lowest pressure your boiler will still work at, and that could be 0.5 bar, it could be 0.6 bar, I know some don't work at 0.8 bar, so that's what you need to find out is what's your minimum pressure. So that behind me is what we need to know when we're first sizing this expansion vessel. Now behind me is an example, so hopefully this example will make it a lot clearer for you. So let's have a look. So the water volume in this system is 150 litres. So the working temperature is 70 degrees C. So how did I work that out? So basically what you've got to do is look at the maximum temperature, look at the lowest temperature the system will ever get to. Shouldn't go below 5 degrees because then it'd start to freeze. So your lowest temperature is going to be 5 degrees and your maximum, then you take your lowest from your maximum and that's what it's going to expand. So that's important as well. So that's how I got to 70 degrees even though my maximum temperature was 75. Let's continue. The maximum pressure in the system is 3 bar, so it's a 3 bar blow off. The highest point in the system is 4 meters. So 4 meters is equivalent to 0.4 bar because 10 meters is equal to 1 bar in pressure. So that's how we got that then. And finally, the lowest pressure in the system, or the lowest pressure the boiler will actually continue to operate at, is 0.5 bar. So that is our example. So let's find out exactly what size expansion vessel we ended up with. Let's have a look at this working example then. So first of all, you can see that I've used a figure of 1.3. So what is this figure of 1.3? Well, basically that's what we're allowing for the expansion of the water, 1.3 or 3%, because it's a sealed system, not at sea level and open to atmosphere. So we're going to use 1.3 for 3% of the expansion. And you can see we've got 150 litres. So 1.3 times 150 equals 195. So that's what we're allowing for, 195 litres. Now you can see we're timesing this figure by 0.023. Well, where's that come from and what is it? Well, that is actually the water dilation coefficient, and it's taken from a chart, and it's taken from this chart here. So we have the temperatures along the bottom and the coefficient up the side. So we find our temperature, we work our way up, and then we go across and it gives us our coefficient. So that's how we find out this 0.023, by going up to the line, where it meets the line, going across then, and it gives us our coefficient. So that's where we got this figure of 0.023 from. We times this 195 by the 0.023, which equals 4.485, as you can see here. So that's the first part done. Did you understand it? Well, hopefully you did. Let's move on. Next thing we need to do is work out our minimum pressure. Now, our minimum pressure from the board here, you can see we are 4 meters from the expansion vessel to the top of the radiator at its highest point. So that's our highest pressure. Because it's 4 meters, we turn that into bar, which is 0.4 bar. So our first reading is 0.4, but the lowest reading in the boiler is 0.5. So we need to take this lower pressure of 0.5 because it's higher than the 0.4. And we need to times this by 0.2. So 0.5 times 0.2 is 0.7. So that's our highest reading, even though it's taken from the boiler, but the boiler is a higher figure than the highest reading, if that makes sense. Now, as you can see, we also need the maximum pressure. Now, our maximum pressure is 3 bar, because it's a 3 bar blow off, and we need to add 1 to this, so 3 plus 1 is 4. Didn't even need a calculator for that one. So we've got our minimum pressure of 0.7 and our maximum pressure of 4 bar. So that's our next lot of readings. Let's continue. Now we have this figure now of 4.485, and what we have to do is we now have to times this figure by this maximum pressure of 3 plus 1 is 4. So we do the 4.485 times 4 equals 17.94. So that's the first calculation we need to do. Now then, the next thing we need to do is take our maximum pressure of 3, not the 3 plus 1, just the 3, our blow-off pressure of 3, and we need to minus this 0.7. So that's our next one, what you can see here. So 3 minus 0.7 is 2.3. Now, as you can see, the last calculation we need to do is 17.94, which is taken from the top here, divided by this 2.3, which gives us a figure of 7.8 litres. So technically we would require an 8 litre expansion vessel for this system. So let's just recap what's behind me, so hopefully you understand it. So let's have a look. So we've got the 1.3, which was our percentage, so our 3% for expansion, times by the litres of water, which was 150. I think that came to 195. Then we times that by the coefficient, which is 0.023, which we got from the chart, which came out at 4.485. We then need to times that figure by our maximum pressure plus 1, which is 4. So we do 4 times 4.485 is 17.94. and then we need to divide that figure by our high pressure and low pressure, which is 3 minus 0.7, which is 2.3, which is now 17.94 divided by 2.3 is 7.8, which gives us a final answer of an 8 litre expansion vessel. So hopefully now you understand how to work out these expansion vessels. So that's working out the size of the vessel. Now let's have a look how we set the pressure in this vessel. Now this is the pressure we're going to adjust our expansion vessel to here. So we need to adjust the pressure in the expansion vessel empty to our 0.7 bar. Now remember, that's what we worked out was the minimum pressure the boiler could have plus this 0.2 because it was greater than our head pressure, but obviously if our head pressure is more, then we would be using that one. Then we need to fill the heating system and bleed all the radiators and adjust the pressure when full and cold to 0.7 plus 0.2. So that equals 0.9 bar. So that's what we're going to be filling this system to with the pressure in the expansion vessel. Now a lot of boilers come out with their expansion vessels already preset to between 0.7 and 1 bar. So depending on the size of the boiler you've bought will depend on the size of the expansion vessel and what pressure they put in there. But just remember, you can't have an expansion vessel with a greater pressure than what the actual system is going to go to, because otherwise the diaphragm won't move, will it? So if you've got a 3 bar in your expansion vessel and you only need it to go to 1 bar, then it's not going to transfer, is it? So now as promised, let's have a look how we're going to size the hot water expansion vessels. So this is what we need to do here. So the expansion vessel for drinking water is designed in the same way as the central heating one. So just change the minimum pressure by the water mains pressure or the switch off pressure of a whole house booster pump. Instead of the heating system volume, the volume of the cylinder shall be used, and if the water mains pressure is too high, making the vessel too big, then use a pressure reducing valve. So that's why most of the unvented cylinders now have pressure reducing valves with them, which reduce the pressure to 3 bar, because if the pressure is too big coming into the vessel, it's going to need a massive big expansion vessel, or the cylinder might need to be really thick to take the pressure. So that's how we're sizing a hot water expansion vessel. Let's have a look now how we're going to test the pressure in these expansion vessels. So let's get downstairs and do that. The boiler we're going to check the expansion vessel in is this 600, because it's the easiest one out of this lot to do, basically because it's on the top here, easiest for me to show. So I haven't got a clue if there's any air, nitrogen or whatever's in this, so first of all let's find out. So let me, so it's 0 on my gauge, on my little pump. So let's connect it on. I couldn't hear anything come out, and according to my pump there is 0. There's nothing in this expansion vessel. Okay, so when we need to pump it up, what we need to do is we need to, because when your system's drained, this is when you'll be checking this and you'll be setting this to your, or in our situation, the 0.7. So that's how we would be doing that. Okay, now there's no water or anything in this, but if you are checking them when you have isolated the bottom, you drain out the water because you can't check the expansion vessel with water in it, and then you open the pressure relief valve and you keep that open while you're putting the air in. So that's the difference between when there's water in the system and when there's no water. So right at the very beginning, this is how we'll be checking it. We don't have to hold anything open. We just need to fill it to this 0.7 of a bar. So there we go. We've got 0.7 of a bar in our expansion vessel. So let's put our 0.7 in that expansion vessel. We would then fill our system, okay, and then we would check it. But we need 0.7 plus 2, so it would be 0.9 then. So we will be putting 0.9 of a bar in. So let's put 0.9 in. And that's our preset at 0.9 in our system when it's cold. So we've checked and set our expansion vessel. It's as simple as that. Does anybody ever check their expansion vessel before they fill them up or after they fill them up? I don't think so. We just rely on the manufacturer. And I know Baxi send theirs out at a bar. They also say in their manufacturer's instructions how many litres of water you can fill the system to, because what size is it? It's an expansion vessel. It's a 7 litre. So this has got 7 litres in there. So if this had 150 litres of water in there, it won't be big enough, would it? Because we need 8 litre expansion vessel. So you can see the expansion vessels are set for what they expect the systems to be on. Even though this is I think it's a 24 kilowatt. No, it's a 30. It's a 30 kilowatts, a 630. So this is a 30 kilowatt, but they expect the heating system to be incredibly low because they've only give you 7 litre expansion vessel. So that's how we fill the expansion vessels up. And once you've disconnected your pump, always check the Schreider valve with leak detection fluid to make sure it's not leaking before you put your cap back on. Now, if this unvented cylinder did have an external expansion vessel, what pressure would we set it to? Well, basically, we'd set it to the same pressure what our pressure reducing valve is. So this is our pressure reducing valve here, or our combination valve, and this is set to 3 bar. So when our system is completely drained, we would set our expansion vessel pressure to 3 bar. And remember, when you're setting the expansion vessel pressure, you can't have it connected to the system, you would have to disconnect it. So whether you're servicing or whether you're installing, if you're checking the pressure in these unvented cylinder expansion vessels, make sure it's disconnected from the cylinder completely, so it gives you a more accurate measurement. Now let's finish off with talking about things that can actually go wrong with these expansion vessels. First of all, you press that Schreider valve in and water comes out and not air, then your diaphragm's gone and water is transferred over to the other side and it needs replacing. If you press the Schreider valve down and just no air comes out, nothing, then there's a possibility that it's just lost its air through the Schreider valve and it could just need either topping up or the Schreider valve replacing. Remember, if you want to check this to see whether it's leaking or not, you can use leak detection fluid, and they're dead easy to change as well. You just need a little extraction tool which you can buy from a bike shop. Because remember, it's the same thing as what's on your bicycle tyre. Now, that's the main things what can go wrong with them. But what would your boiler be doing to tell you that this expansion vessel's gone? Well, if you've got water coming out your PRV, your pressure relief valve, then it could be every chance that there's something wrong with your expansion vessel. Or the PRV could be broken. Or you could have left your filling loop on and it could be the filling loop passing. But always check your expansion vessel to make sure that it's still charged. But remember, you can't get an accurate reading unless the boiler is empty of water. So let's have a look and see what could be happening to the potable water expansion vessels then. Now the potable water one is pretty much the same. Press down the Schreider valve and water comes out, then the bag inside is split and needs replacing. Press the Schreider valve down and just nothing comes out, then you might just need to recharge it. Okay, and then again remember to check the Schreider valve's not leaking and replace if you need to. So what would your unvented cylinder be doing to tell you the expansion vessel has gone? Well, the temperature pressure relief valve within the cylinder is connected to a discharge pipe D1 and D2, which are separated by a visible tundish and air brake. So if you've got water coming through there and you test the temperature of that water, so if the temperature's, I don't know, 20 degrees or so, then that's not the expansion vessel. That could be just your pressure relief valve on your combination valve. If the water coming out is like over 89 degrees, then that could be something like your cylinder stat has gone and it's kind of boiling the water within the cylinder. But if your water is between 50 and 65 degrees, so if it only leaks then when you've actually got your boiler on to heat the cylinder or your immersion heaters are on to heat the cylinder, then there's every chance your expansion vessel has gone because it's not taking up the expansion of that water when it heats up. Pretty much the same as your central heating one. So that's how we know whether the expansion vessels are broken. And that is the end of this video on these expansion vessels. So if you've liked this video, why don't you give me that thumbs up or leave a constructive comment down below. But remember, be respectful. If you're not subscribed to our channel, then please subscribe because it helps. And don't forget to hit that notification bell because you want YouTube to tell you when we're uploading these videos. You know, Mondays and Wednesdays. All I've got left to say is, thanks for listening, thanks for watching, and I'll catch you on the next one, guys. Cheers.